So let's go ahead and take a look at today's warm-up. Today's warm-up asks, what is the scale factor for the pair shapes? Notice this is two problems, so we're going to go ahead and solve for two different scale factors. I'm going to go ahead and cover this one right here so that we're only paying attention to one question at a time. So let's not pay attention to that. Let's just go ahead and pay attention to this question here. So remember, a scale factor is a number that helps us convert the smaller shape to a bigger shape. Or it could be the other way around. It could be the bigger shape to the smaller shape. It's the number we multiply to get to the other shape. Well, in order to find the scale factor, we need to first know its corresponding sides. Well, corresponding sides are our matching sides. For instance, this 64 matches this with this 192. This 42 matches with this 126. What we want to know is what number did we multiply 64 by to get to 192. Whatever that number is going to be the same for 42 to get to 126. We need to know what number we multiplied by. The easiest way to do this is to get the biggest number and divide it by the smallest number. So 192 divided by 64 will lead you to 3. So that means 64 times 3 will get you 192. You can also use this number here and this number here. 126 divided by 42. That will still get you 3. So you're multiplying by 3. Because you're multiplying by 3 consistently, your scale factor is times 3. Now, let's go ahead and take a look at the other problem. All right. So let's go ahead and have a look at this question. This question is a little harder because the scale factor is not as clean as the other one. So let's go ahead and identify the corresponding sides. This 6 corresponds with this 15. This 4 corresponds with this 10. We want to know what number we multiplied 4 by to get this number, or we want to know what we multiplied 6 by to get this number. Well, 6 does not go into 15 very nicely. And neither does 4 go into 10 very nicely. So what I'm going to use is a method called, I call stacking. We're going to take this 4 and we're going to see how many of these 4s it takes to fit this 10. Let's go ahead and put 4 in there. If I put 4 in there, it might cover about this much. Well, 4 is not enough to cover that much. So let's go ahead and put another 4. All right, I put another 4. Now, this only covers 8. So 4 times 2 is not enough. I have to put 2 more in. Notice that 2 is half of this 4 here. It takes 2.5 or 2.5 of these sides to make the 10. So the scale factor is times 2.5. It should come out the same for the other side as well. So let's go ahead and erase this and see if that is true. So let's go ahead and have a look at that. For this side right here, we're going to see how many 6 does it take to fit this 15. Well, we know that 6 cannot fit into 15 perfectly. But let's see how many does fit in there. We can go from here to here. Let's pretend that's 6. Obviously, 6 is not going to cover the whole thing. So let's add another 6. Well, 6 plus 6 is 12. We still didn't cover the whole thing. We'll need to add another 3 to fill out the whole thing. Notice it's taking 2 and a half of that 6. So we can multiply 6 by 2.5 to get that side. So our scale factor is times 2.5.